In this video, we're going to be talking about how you can write electron configurations using noble gas notation. And to be more specific, in this video, we're also going to be focusing on examples using main group elements. So we're doing that because the transition metals right here and the lanthanides are a little bit more complicated, so we won't be doing that in this particular video. So the rule for writing the noble gas notation for something is pretty simple. It is you take the noble gas immediately preceding your atom or ion. So what do I mean by immediately preceding? That means we want the noble gas that comes right before it. So you go up a row and then you go over to here where the noble gases live. And you put that in brackets, and then you write your other electrons. And you write your other electrons using the same notation that you normally write electron configurations in. And if you don't remember what that is, we'll go through a couple examples right now. So hopefully it will become more clear. So before we get started, I'm just going to remind you why we call the noble gases noble. And that is because they have a full octet of electrons. And so since they have a full octet, they're not very reactive. They have all of the electrons they want. And as a result, you will see in chemistry that a lot of chemical reactions will be driven by other non-noble gases trying to get a full octet. So the first example we're going to talk about and write the configuration for is silicon. Silicon is right below carbon in the periodic table, and we can write its full electron configuration just for comparison. So if we start up here with hydrogen, silicon has the electron configuration 1s2, 2s2, 2p6. So as a reminder, these are our s electrons because they're in s orbitals. These are our p electrons because they're in p orbitals. And then once we're through our 2p6 electrons, we go to 3s2. And we have 2 more electrons, so it's 3p2. So that's the electron configuration for silicon. Now we can write it out using noble gas notation and compare. So the noble gas immediately preceding silicon, if we go up a row and then move over, we see that it's neon. So we write neon in brackets. And then the other electrons are the ones that come after neon. So we go down, and the electrons that aren't included in neon would be our 3s2 electrons right here and the 3p2 electrons. So if we compare these two ways of writing our electron configuration, you can see that these electrons right here, so everything up to 3s2, 3p2, that gives us the electron configuration for neon. And so we don't have to write that, we just write neon and assume that whoever's reading it knows what the electron configuration for neon is. The other thing you might notice is that these other electrons here that we wrote outside of the brackets, these are our valence electrons. So writing your electron configuration this way using noble gas notation makes it really obvious where your valence electrons are and what kind they are. So that's helpful. We are going to go through one more example, and that will be calcium. So calcium is over here. And so we're not going to write the full electron configuration this time. We're just going to write the noble gas notation. So calcium, the noble gas immediately preceding it, we go up a row and then over, and we see that the noble gas is argon. So we write argon in our brackets. And then what electrons are not in argon? So we move down and we see that we have our 4 s electrons and we have 2 of them. So this is the noble gas configuration for calcium. So does calcium have a full octet? And we know that these are the valence electrons. And we also know that if it did have a full octet, it would actually already have a noble gas configuration. So it would either have krypton or argon, and in this case, it turns out that calcium prefers to lose 2 electrons as opposed to gaining a bunch. It would be gaining 10 plus 6. So lose 2 electrons. And when calcium loses 2 electrons, it becomes the calcium 2 plus cation. And then we can write the electron configuration really short, or it'll be really short, because we know it's going to lose these 2 valence electrons, and then it will have the electron configuration, which is just the same as argon. And we can tell really easily looking at this that calcium 2 plus has a full octet. So one of the many pros of writing things in noble gas notation, besides the fact that it, makes your hand less tired, is that it makes it really easy to see where your valence electrons are and whether or not your ion or atom has a full octet.